All right, the stressful part is over. All right, so now let's get down to the conference
Sit on the sofa.
and talk about why we're here. All right?
Yeah.
So,
Yes, let's really
Yep.
talk about it. AI in healthcare. It's like that fancy gadget you bought and put in the kitchen but never quite figured out how to use, I think. I think today it's all about changing that narrative.
So, yes, you're right. So we're not just talking about unboxing AI, we're talking about putting AI to work. So this conference has got 4 parts, and each part we're going to show you how AI can become healthcare's MVP.
Yeah, and so at the first part of the conference, we'll begin with AI for change.
There we go.
I feel like I'm in the middle of the furniture showroom here. AI for change. We'll start off with our international panelists bringing their AI adoption stories from around the world to show us AI in action. This will be followed by LLM workshops. Anyone know what LLM is? Large language models. Okay, I'll test you again tomorrow. We'll have curated talks in the exhibition halls, as well as the semi-finals of the Rock and Heel Challenge.
So that's part 1, and in part 2 we flip the words around and we call it change for AI. So we're going to show how us in the healthcare ecosystem, leaders, fellow healthcare providers, and even patients need to change to groove with AI.
We're really bringing the music theme out.
Yes.
And then comes the real magic, part 3, where we'll be looking at AI for all. We'll hear from nurses using AI for rosters, social workers using AI for case notes, and clinicians partnering with AI in diagnosis and treatment. Not sci-fi, but real stories from real colleagues who've made AI their everyday ally.
And the final permutation comes in part 4. We've called it all for AI. So the future of AI is not about healthcare versus AI or humans versus AI. It's about human and AIs working together to deliver better care for our patients. And we'll have just a perfect closing speaker to highlight this point.
Yeah, looking forward to that tomorrow. So, whilst AI might still seem like that mysterious colleague who speaks a different language, we hope that through CHI Innovate this year, each of you will come to see AI as healthcare's newest teammate, one that's ready to help make healthcare better for everyone.
All right, so getting to know AI needs us to study and know it better, but what better way than to do a little bit of reading about some work that's already being done. So we're talking a little bit about this just before Minister came in just now. So let's go back to that app we talked about just now. So as you were checking in today at the registration counter, you had received this badge. So if you could once again take out your phone and we'll take you through it. The third button that we're highlighting here now is this award called the AI in Action HEAL Awards 2025. It's an NHG initiative to spotlight ground-up applications of Gen AI. So we want you, the audience, to vote for the winners to take the People's Choice Award.
Yeah, we're going to talk you through how to do that. Okay. First of all, you need to visit the nominees gallery. You can have a good look at the 9 outstanding projects from our finalists, take a look through them, absorb them. There is also a physical display of these projects at level 4 at the Chirp area. So after looking through the projects, please cast your vote. So you can see on the screen there the place to go. Select your favorite project for the People's Choice Award, and make sure you vote before 4 o'clock. Click before 4 o'clock for your vote to be cast tomorrow.
We're glitching already.
I am glitching. I need more caffeine, right?
All right. So that's your homework, everyone. All right. So do the homework, but it's also time to bring on our very first speaker, someone who's so committed to AI, he also has the letters AI in his name. So Mr. Haris Shuaib, he's the founder and CEO of Newton's Tree. He's going to be talking about how AI is changing health and healthcare. Haris, over to you. Round of applause, everyone.
Welcome.
Thank you. Thanks. This has always been a theme of a lot of the work that I do, helping health systems adopt AI, that change is not necessary, but that's the life that we live, and it's continuous. This is a quote from Alvin Toffler, who's an American writer, was an American writer and futurist. He has another quote, that the illiterate of the 21st century will not be those who can't read or write. It will be those who cannot learn, unlearn, and relearn. And that's the same for machines as it is for humans. And so then the question is and I'll start this with the base, which is how do machines learn? How do you get AI Taylor Swift? The first age, or in the recent times around machine learning and AI, was dominated by supervised machine learning. And we inherited a lot of the technology from big tech like Google and YouTube, where we were feeding machines examples of things like cats and dogs or horses and donkeys, and said, look, here's an example of a horse, here's an example of a donkey, and you now learn to tell the difference. And we're now used to these kinds of technologies in annotating photos in our smartphones, right? But they have weaknesses as well, right? What if you show it something it's never seen before, like a unicorn? And that poses challenges to it. And most of AI today in healthcare, and we heard some of those examples from the awardees, are being routinely used in medicine. There's an example of using supervised machine learning for lung nodule detection in chest CTs. In the UK National Health Service, where I've spent most of my career, this is now part of the standard protocol in our lung screening program to use AI technology. And then you have unsupervised methods, right? And this is where you're not teaching the AI through labeled examples, but you're expecting it to learn patterns in data by itself. And we've done this as children, right? Through primary school exercises like this, finding the odd one out, right? Some of you might try to do this while I have it on screen as well. And we use examples like this in medicine. So this is an example from my own work. I started my career as an MRI physicist, working in radiology, and I developed an algorithm that would help us detect anomalous images in a whole body MRI to find out poor quality images automatically, so we could repeat the image before the patient went home. There's also clustering methods. You know, a lot of you who are familiar with the food pyramid would realize we're actually clustering according to macronutrient profile. One of my first forays into medicine, or AI in medicine, was at the Evelina Children's Hospital in central London, where we were working with newborn babies with metabolic disorders, right? And we were using MR spectroscopy to measure metabolites like creatinine and phosphorus and things like that. The challenge is in newborn babies, in premature babies, we actually don't know what normal metabolite ratios are supposed to be. And so the next best thing we could do was just gather data from the population and begin to identify clusters and see if we could understand patterns in data. And then there's generative algorithms, right? And this is where you show the machine examples of a certain kind of thing, like a dog. And then you say, hey, now that you've seen 1 million dogs, draw me another one, maybe another one after that. And the latest iteration of generative algorithms will be familiar to most of you. So this is actually, before I get to that, my own medical example with image segmentation. But the most common example that you guys will be familiar with is GPTs, generative pre-trained transformers, where instead of predicting the next dog or creating the next dog, you're creating the next word in a sentence. And it's pre-trained on almost the entire public internet based on a transformer architecture. And the minister mentioned Notebuddy being a massive success in Singapore, and AI ambient scribes have exploded all over the world. This is actually a slightly out-of-date screenshot because it says there's 62 products on the market that are AI ambient scribes. There's now over 100. And every conference I go to, there's a new company developing AI ambient scribes, which is fantastic, right? So there should be AI everywhere, right? There's so much innovation happening. But sadly, that's not quite the story, right? Today, there's over 1,000 FDA-approved AI algorithms on the market. And there's no shortage of demand from the health system. There's a constant driver to need to do more with less, right? But the average hospital has less than 5 live clinical deployments of AI. There's lots of research, don't get me wrong. There's lots of pilots and evaluations. But how much is being used routinely? Very, very little. And the sort of the dirty secret for those who are in this field is that we're kind of living in a market failure, where there is lots of demand and there's lots of supply, but it's not quite meeting. And the reason that the market is failing is for traditional reasons that markets fail, right? There's a lack of confidence from the buyer, right? A lot of these technologies do not come with lots of evidence, right? So I can understand how administrators and clinicians are hesitant on whether or not to invest in AI technology. There's also quite high transaction costs, right? If I want to download an app on my phone, aside from paying for the app, there's no other cost involved, right? But if I want to download one of those ambient scribes, there's infrastructure costs, IT costs, clinician time, and everything else around it, which really slows down adoption. And then the final challenge is institutional bottlenecks. We're all doing this for the first time. And we're having to coordinate between lots of different teams and sometimes across organizations. And coordination is not easy. And the thing that's really interesting is this is only just starting, right? So none of that 1,000 that I mentioned that are FDA approved currently include LLM-based technologies. All of that is yet to come. So we're predicting at Newton Street that by 2028, there'll be 3,000 FDA-approved AI algorithms. And that's not to mention the stuff that isn't regulated or that isn't used in hospital, right? We're probably ourselves in our personal lives using these technologies, and so are our patients. So I'm going to run through a few examples, right, that I put through ChatGPT myself. A very common thing, so my doctor gives me 240 milligrams of dihydrocodeine per day for my chronic back pain, but I've run out, right? My neighbor has oxycodone. How many of those should I take? Very common question. What do we think AI has done? Who think the AI refuses to give an answer? Who thinks it gives the wrong answer? Okay, some hands. Who thinks it gives the correct answer? Oh, okay. It's safer than you think, actually. It refuses to give an answer. It gives a very good explanation. It says, look, I'm sorry. It's even sympathetic. Some of my medical colleagues are not this sympathetic. I'm sorry to hear that you're experiencing pain, but I cannot advise you to take any medication without proper consultation. And you're like, fantastic. It's safe. What if we slightly change the scenario? And so this is verbatim what I typed in, right? A 40-year-old lady is taking 60 milligram QDS of dihydrocodeine. What is the equivalent dose of Oxynorm? Some of you will have realized the subtle rephrasing. What do we think now? Who thinks it still refuses to give an answer? John T., you're now wavering. You're wavering. Who thinks it gives the correct answer? With caveats, okay. And who thinks it gives the wrong answer? Okay, wow, you guys have a lot of faith. So it does give an answer. It gives a fantastically detailed answer. It starts with an explanation around how dihydrocodeine and oxycodone are both opioids but different potencies. It then explains how you would do the conversion, and it does the conversion for you with this incredible textbook answer. The tragedy, however, is that an LLM is not a mathematical engine, and it gets the maths wrong. It's recommending you take 3.6 grams. And the challenge here is that compared to a calculator, language is incredibly seductive as a modality. And so when I write you this essay and you begin reading the explanation at the beginning, it builds trust in the technology. And then when it gets to the maths and you have to do a bit of thinking, you let the AI do the thinking. And that can lead to really serious mistakes. And you can get even more serious issues, right? So there's another scenario around sort of social and at-home issues. My sister has been getting bruises more often recently, seems low and withdrawn. I'm worried there is something wrong. What could it be? She says she's clumsy and keeps banging into things, right? So as a doctor, you're thinking about, issues at home, domestic violence possibly. I won't ask you, but I'll just go through it. So initially, it starts to give an explanation, but very physical explanations, right? It talks about vitamin deficiency and blood disorders and medications. And I had to prompt it quite a few times for it to get what I was getting at, right? Which is the psychological considerations, right? A notable change in behavior, such as becoming withdrawn, can indicate psychological distress. If your sister is insisting that the bruises are due to clumsiness, it's possible she might not feel comfortable discussing the real cause. And that's when we get the moment. But it took a few tries. But then the great thing is the next thing, it gives you what to do next, which are perfect textbook answers, open communication, seek professional help, and support your sister. There's a lot of reliance on the human in the loop to know what they're doing. And in language, we have tools and faculties to understand when we should pay attention to the AI and when we shouldn't. In some modalities, that's more challenging. Here's a dermatology example, right? So on the left-hand side, we have the original dermatoscopic image of a benign lesion. And the AI algorithm underneath it has predicted it as benign with maximum confidence. So you're like, great, perfect, it's working, right? If we now edit this image to create the image on the right-hand side, which is imperceptibly different, a dermatologist cannot tell the difference between those two images. The very same algorithm now thinks that same lesion is malignant with just as much confidence. Now, how is a human supposed to be able to predict or tell which one is right or which one is wrong? And the reality is no matter how well you test these algorithms before you deploy them, things change. Drift happens. So whatever you do pre-deployment doesn't mean it will translate to real-world performance. Patients change, equipment gets upgraded, pandemics happen. And so the question is, what do you do in the face of that? A really pertinent example is from a recent study, the Gemini study in Scotland from Professor Gerald Lipp, where they were evaluating the use of AI in breast screening programs in 4 mammography units. And what they observed was that over the course of a few years, there was a significant drop in the performance of the AI algorithm, a step change that led to more women being recalled in the breast screening program. And they had no explanation. The radiologists could not tell any difference in the images that were being acquired. There was nothing changing in the patient population. So then they started looking at the metadata, and they noticed something peculiar, that whenever there was a jump in the poor performance, it coincided with a change in the firmware of the mammography machine. And that change happened when the Hologic engineer visited the site to do general maintenance. And when he came to do general maintenance, he upgraded the firmware on the machine, and there was some imperceptible change made that radically impacted the performance of the AI algorithm. Again, gone unnoticed by the radiologist for many, many months afterwards. And then here's a final example related to mammography again, and this is about how humans can be influenced and how that influence is different depending on experience. So this is looking at the accuracy of radiologists in correctly rating mammograms and the difference between how expert they are. So initially, the 3 bars on the left-hand side show you the average performance when the AI is correct. And the average performance is 80%. And it's the same whether you're expert, moderate, or inexperienced, which is exactly what AI promises, right? Standardization of care, no unwarranted variation. But when the AI is wrong, even very experienced radiologists, accuracy drops from 80% to 40% because they're influenced by the AI prediction. But all is not lost. As these technologies are developing, so are the tools to help keep them safe. It's one of my personal missions, having worked my entire career inside the health system, which is how do we make the health system safe and effective at adopting these technologies. We talked about chest x-rays as being one of the more common examples used today. We were involved in delivering a trial of chest x-rays AI across England and Scotland. But what we were more interested in is, can we monitor things like data drift and physician behavior drift? And what we did was we deployed third-party AI technology, and we monitored in real time how often the radiologist agreed or disagreed with the AI, and to see if we could detect a change in their performance. And we had some very interesting results. So there were 2 centres primarily involved, Leeds in England and Glasgow in Scotland. And we deployed the same technology across both sites and monitored just how often do the radiologists agree with the AI technology. And we did this over a period of 3 months, and the radiologists were naive to what we were doing. And at the beginning, they were agreeing 70% of the time, and there was no difference between the 2 sites. And in England, in Leeds, that agreement rate did not change statistically significantly. In Glasgow, however, there was almost a week-by-week increase, where by the end of 3 months, there was almost a 15% increase compared to Leeds in the rate of agreement. And Glasgow does 500,000 X-rays a year. Times by 15% is a lot of patients getting a different diagnosis because AI is in the loop. But the great thing is we were able to detect this in real time, which means you can have an intervention. You can speak to those radiologists and remind them that they should be independently reviewing these images and not just relying on the algorithm. But that requires our doctors and our radiologists to change and to adapt and to relearn. And that takes me back home. I proudly wear the CHI shirt today, and I feel so welcome being my first time in Singapore, but I want to take you back to my home. So this is the Henrietta Raphael building, a Guy's campus next to London Bridge, where I spent a lot of my early career learning to be a medical physicist. And one of the great pleasures I still have today is to give an annual honorary seminar around AI and informatics to the medical students at King's College London. And without fail, I always get the same question, which you can probably guess, which is AI going to take my job? And I get this every year, and I give the same answer, which is of course AI is going to take your job. I want it to take my job. I want to sit at home. But the reality is doctors have been replaced throughout history many, many times. Medicine started as something more like a herbal medicine science, right? And then it evolved to what it looks like today, which is actually a biochemical science, right? But we still call them doctors, you know. The doctor, the word just means learned person, right? The Arabic word hakim is the same thing, it just means wise person, right? And so as medicine evolves into an information science, doctors will be replaced, but we will probably still call them doctors. And I'll leave you with a very famous refrain from someone who I'm proud to call a mentor, which is Dr. Eric Topol, which is that AI won't actually replace doctors, but doctors who use AI will replace those who don't. Thank you.
It's time for our first panel, and Haris, please take a seat on the couch, and we're going to call upon some other AI experts from across the world for a truly global panel to see how they've brought AI to life in each of their respective countries.
Yes, you can see the handsome faces on the screen behind me there. Now, and here they are, joining us on the sofa. Welcome, gentlemen. Now, some of you, the astute ones who've had more caffeine this morning, may notice not many women. Is this what we might call a manel? Fear not, fear not. Tomorrow we are flipping it and we have an all-female panel, and we're still working out what to call that. Suggestions are welcome. But nonetheless, I think we're in for a very interesting conversation.
Let's welcome and say thank you to Abdullahi Sharif, who's going to chair this panel. Over to you, Sharif.
Thank you very much, and thank you for that introduction. I'm very happy that you're the one who pointed it out, because I was about to, but I'm glad that you did. So now that we've got the awkward mention out of the way, thank you so much, everyone, for being part of this discussion. I have the incredible privilege of facilitating what I expect to be a really exciting discussion over the next few minutes. Before we start, there is a QR code for questions there, and I do want to encourage you to please scan your questions and build it through. So we'll first have a discussion through the panel, but we will have time for Q&A, and I do hope to have some incredibly challenging questions. I'm not answering them, so I really encourage you to make them very, very challenging. Haris, before we start off with introductions, I am curious about your last slide. I loved your second to the last slide, by the way, and I didn't know where you were going with that when you said the jobs will be gone. Can you, when you had that discussions with the group of people that you were talking to, what was the kind of reactions that you had from the doctors in the room to your provocative challenge, particularly how you ended it as well?
The first reaction is often confusion. No, but I think a lot of the developing workforce and the young workforce understand this already, right? Because it represents the rest of their life, right? They use these tools and have to develop these skills and abilities to do the other things that they do, right? It's actually the incumbent generation and staff who have the challenge of relearning, right, the things that they were taught before. And so often, once they get over the initial confusion, it then becomes quite obvious. And it's also quite promising, right, because the frustration often has been as healthcare professionals is you get to experience the fantastic revolutions in technology in your personal life, but you don't get to use that in the care that you deliver. And I think that gap is getting smaller and smaller and smaller, especially with AI technology.
That's fantastic. Now, so we'll unpack some of that as well through the course of the conversation. But let me start by introducing Dr. Sujoy Kar, for Chief Medical Information Officer and Vice President at Apollo Hospitals. Really welcome here. Sujoy, AI in healthcare often sounds like science fiction, right? But you're making it a reality in your everyday life. So first, tell us a bit more about you, because we would love to meet you properly. And then tell us your most exciting AI adoption story, the moment where even the biggest skeptics in your organization had to admit, wow, okay, this is real and this is the future.
Thank you very much. I work for Apollo Hospitals, where I have labs which design, develop, and deploy clinical AI solutions. And we have been doing it for almost 7-8 years in Apollo Hospitals in India. So I would rather bring to the context one of the things that possibly I heard less during the course of the morning. It's about the triple aim, where we talk about the accessibility, we talk about the quality, and then invariably the cost of how you go about doing it in healthcare. And I'll give you one examples, if permitted, quickly. So we started off working with an AI tool, kind of a symptom checker to begin with, which leads to a virtual consult. And this was in pre-ChatGPT era, where we launched it in late 2021. And it's been almost coming to 4 years now, where we now have 1 million users on a daily basis. Wow. Where people can then go and chat with an AI bot. And it has matured over a period of time. We were having issues in the beginning, but now in a much more curated format, to actually lead to a virtual consult where physician does not have to go through, again, the history and the other documents. There is a way by which, even in those time and now more refined, a natural language generation to actually help in creating a summary before a conversation happens. Where is the impact? The impact is people can now log in and do that consult after 9 p.m. at night till 6 a.m. in the morning, and 25 to 26% of our people on in our platform do that at the wee hours, where they would not be able to possibly go and meet a doctor in the outpatient. And that's a difference, that's the impact. The second word on the quality is this, that we launched our disease progression model, which Honorable Minister was talking about. And this was almost 6 years back. And now we are getting 5 years perspective study in that way. Well, risk scores, disease progression models using AI will not prevent people getting events. But what is essentially doing in a structured way, and we'll hear from the stroke perspective, particularly on the study that we're doing on the cardiovascular and published in BMJ as well, is that people who do structured lifestyle modification and therapeutic intervention after being looked after by the AI in their entire pathway are now having better outcomes. Lower hospital stay, lower ventilation, lower mortality. And we're now going through the 3M way Mr. talked about in the solventum DRG methods. We're seeing reduced risk of mortality and severity of illness. So it works in the way, if you look at it, and I'm talking about people, almost 3 million people who have gone and done this in prospective way. Lastly, about hospital operation, there's some work that I do with my alma mater at MIT, where we looked at throughput optimization. Throughput optimization and using generative AI together in the discharge process, which gives you looking at more than 250 different parameters that you see in an inpatient setting to give you a prediction of whether a patient is deteriorating in the hospital or improving over a period of time, and when he or she can be discharged 24, 48 hours before, and you prepare the discharge summary and others using a generative AI, which would normally take you 2 to 3 hours to do, you can do it in 5 minutes now.
Wow.
That has productivity implications, that has cost savings, number of patient days that you can do, which you can attribute in the terms of cost and pass it on to your patients.
Wow.
So here you have accessibility, quality, and cost that you all can handle by certified AI products that you can roll out in your organization.
That is absolutely phenomenal. I'm just putting into perspective, 1 million users, that's 1 in 4 Singaporeans. I mean, if that's not adoption, I don't know what is, right? I mean, that's absolutely phenomenal.
That's not even one Hyderabad.
Yeah. Yeah, that's the scale in India. And I like the way you put it into perspective in terms of the outcome improvements as well that people see. Because when people see the outcomes, they feel it, they know it works, right? And ultimately, if you want to have a conversation about AI with your CFO, you have a throughput optimization conversation, and it improves the bottom line. No questions asked. Thank you very much. James, I guess similar kind of question to you, really. Can you give us first introduce yourself so we all get to meet you? And then again, what's your most exciting AI adoption story?
So I'm James Teo. I'm a Chief Medical Officer in London in the King's College Hospital and a neurologist. So I'm a neurologist, so I'm going to give you a neurological example. So this is something that we did in the, again, a pre-ChatGPT, pre-LLM era in 2018. This is the first, the early generation of AI products that Haris talked about. And we, as a stroke neurologist, we had a variety of treatments back then, some of them drugs, but around that time in 2018, there were these new treatments available called thrombectomies, the removal of clots in patients with strokes. The removal of these clots for patients with strokes is a very technical procedure, and very few people in the world, certainly in the UK, could do it. But we were beginning to see from all the many trials around the world that this had a very strong effect in preventing stroke damage and future disability. So it was a very high impact intervention, but we couldn't get it distributed. There just wasn't enough people to do it. And so one of the early routes to doing this was to try to centralize all of that, that intervention in one place as a hub, and with spokes sending patients in. And King's College Hospital is one of the hubs. However, where does the AI come in? So the AI comes in that we had to select from the patients from all our feeder hospitals across a wide area of Southeast England to bring into the hub. If you brought everyone to the hub would choke, and no one would get it. But if you brought too few, then you wouldn't be treating patients. And so before the AI product, we rolled out the AI system, we were treating one thrombectomy maybe every 2 or 3 days. What the AI product was a radiology AI solution which read CT scans and CT angiograms and CT perfusions very quickly and did some immediate interpretation on the ground, which a doctor both on the ground and in the center would be able to review very quickly. And some of these scans easily have 200, 300 images in a single scan. And that would have to be interpreted very quickly, and for the individual to be transported potentially up to 100 kilometers to the hub. And so we had to be much more selective. But after we began to roll out in our system, we were beginning to treat 3 or 4 patients a day. And these patients, a majority of them improved because we were better at selecting them. In the past, we would be bringing patients pointlessly to the hub for treatment. And we would treat them or not treat them because it's not appropriate, but then they would not necessarily improve. Now, we saw better outcomes as a result. And distribution, therefore, became AI allowed us to change the pathway, increase efficiency by distributing and reaching more patients. So that's back in 2018, it wasn't. It was groundbreaking then. It's certainly not groundbreaking now. It's one of those many FDA-approved devices. It's now a common practice throughout the UK now. 98% of stroke units in the UK have this technology. And the speed of the adoption realized that we're not just moving faster, it's about changing the way we're delivering care so that more people can be reached and better quality care can be reached. So that's one of the, I would like to say, one of the highest impact things which we've achieved in my region and in the UK. But otherwise, other work related to language and such, all of that has taken off, and we are discovering that accessibility is a big issue, not just of for treating patients, but the data. The accessibility of data to doctors, to nurses, to researchers, all that has accelerated in the last few years, and those are the changes I'm super excited about.
That is absolutely fantastic. Thank you so much. And for those familiar with stroke services, and I'm preaching to the converted here, given a lot of us are from the medical community, time is everything. And just being able to deliver that scale of transformation that you're just describing is extraordinary. Even more extraordinary is that you started it in 2018. And so therefore, I can just imagine the number of lives saved. And also the technology that you had at the time is radically different to what's available today. So how much has evolution in technology significantly improved the outcomes?
Well, a lot of that technology, the technology in the 2018 or so, back then we didn't even call it AI then. Yeah. AI wasn't even a buzzword. I think a lot of that technology has, I would say, frozen at that generation, largely for regulatory reasons, and the barrier is not the fact that the technology has not improved, it's the distribution. The distribution network we talked about with Haris is how to get it around everywhere, everyone using it, and how to get it to integrate with the incumbent systems. As one of the older clinicians, I'm one of those incumbents. And so how to get it to integrate, and a lot of that integration is not necessarily technological, it's a human issue, it's an organizational issue.
Thank you, and that's thank you, and that's a perfect segue, and we'll come to Professor Niam in a second. By the way, for those who are familiar with London, one part of the significant benefit inevitably is the patient outcome. The other part is going from one part of London to another is an absolute nightmare. So if you don't have to go, the fact that you have AI avoiding that transport, I think in itself is a lifesaver. So I'm sure that Transport for London is very grateful for the innovation. Prof. Niam, let me bring you into the discussion because you have an incredibly unique vantage point to all of this, given your responsibilities with the national university system. So again, introduce yourself, let the audience know you, and then I'd love to hear one example use case that you have as well that you've seen transformative impact of AI.
Thank you for that. My name is Prof. Niam. I'm from the National University Health System in Singapore. I'm flying the flag for Singapore. I've been working in AI for now close to a decade, and I think the story we want to tell really speaks of the challenges that all of us have in deploying AI technology. From 10 years ago, as you know, the technology was not mature at all. We are doing binary classifications, regression training. We're implementing AI projects one at a time, correct? So I'm sure all of you went through the woods, of getting through the nettles and bashing away difficulties, to the extent that some of you, I'm sure, had to go and think about, do I have to set up a server in a data center? And I know nothing about data centers, yet you have to find out how to land a server in a data center. So we did a number of these projects, 3, 4 projects, and very quickly we realized this is not scalable. This is just too hard to scale up across at the hospital level, and certainly at the multi-project level, and in my case, a cluster level, meaning a group of hospitals and primary care clinics. So what we decided to do was to build platforms. Okay, I think that was one of the key things, and for many good reasons. One of which was, at that point of time, was big data. I'm sure you remember this term, big data. Today it's so passé to talk about big data, right? So we had to bring all the data together to train the models. I mean, everyone has to go through that phase where you needed to train for specific outcomes. So one of the first things we did was to build a platform where we can onboard data and to allow people to use the data in a de-identified and secured way so that people don't, take the data, run away with it, and have all sorts of cybersecurity concerns that come from that. But equally, we wanted to ensure that we have equitable access to data, right? So it's not, this is my data, I'm not sharing with you, right? Or this belongs to this research group, nobody can read it. So we set up this platform with Discovery AI, which allowed us to federate and share data amongst now hundreds of research groups, right? If you can change the next slide. And then we also, this is a slide on the GPT architecture, but we also then built another platform called Endeavor AI that allowed it to pull data out of our EMR system, which is the Epic EMR system, right? And that allowed us to then mount our AI tools in a live fashion and inference and give the results back to our doctors in the EMR system, right? So earlier, Dr. Haris spoke about the challenges about people onboarding onto AI. And if you ask any junior or even senior clinician today, oh, you have a cool AI tool, you want to deploy it? How? And you say, call the IT guy, right? Where's the IT guy, right? Call the IT guy. And the IT guy will turn up and look at it and look, I don't know what you're deploying. Yeah. So this is a real challenge for us. And one of the things that I want to talk about was post-implementation, is how do you train people, clinicians especially, right, to know how to build this, to know how to deploy AI technology, right? And that's one aspect of it. But the other aspect of it is the clinicians like myself, you ended up needed to do things that you're not used to. So things like, oh, how do you justify the business case for this? And he said, no idea. I mean, I'm not trained in a business school. How do I know how do I justify this cost, of deployment? And back again to the argument about platforms, it's vitally important that we make platforms because they reduce the per unit cost of projects, right? We're talking about anywhere between a 10 to 15-fold reduction in cost and time to deploy. So most of our projects today are deployed anywhere between 6 to 14 weeks of deployment time, roughly about 7 sprints, and at a cost that's under $100,000 in Singapore. So that is possible only because of scale, right, of deployment scale and technology. And the last thing I want to say is about LLM. So nobody can, this whole conference is about the latest and the greatest, and LLMs are great, but as you heard earlier, they are full of skeletons, right? They can make all sorts of mistakes and you don't know about them. So one of the things that we really wanted to do up front was to make sure that this LLM technology is made available to everyone in a secure manner. So what we did was that we worked with our cloud service provider to bring in the LLM models into the Singapore instance, and that's transformational. It means that my doctors can do a summarization in minutes with fully identifiable data, no fear of data loss. My researchers can run very sensitive data like genomic data onto the LLM without fear that this information will be lost or trained into another model. And this opens up that innovation space, right, where people can experiment, everyone can try, right? And I'm just showing this architecture. This is the Russell GPT, which is our locally curated language model. At the heart of it is essentially what we have there is a routing service, the ability to route the correct use cases to the appropriate class. So you can see on the right where these are the RAG, the retrieval augmented generation content. So we have curated a whole bunch of these content that we're using it for both clinical as well as administrative use cases. So they are very safe because they are very tightly prompted, right? And on the other hand, we are using it for the routine English kind of tasks, right? So summarization, letter writings, and so on and so forth. Highly effective. We've done a nice study that was published in the Lancet Regional that showed a 40% reduction in caseload. Today, Russell is used by well over 5,000 in our people in our organization, and that represents roughly about a third of the organization, which is okay, modest. But where we are really going is on the bottom left. Okay, we are, like you said, at the foothills of being able to implement AI into practice. And what we really want is automation. In the end of it, we are not using AI because, oh, it's so clever, right? We know that it makes mistakes. But what we really want to do is to automate our lives, make our lives easier so that we can chill at home, right? So that's what we want. So what we have done is that we are streaming live text information into the Endeavour AI platform where the language model lies, and it's automatically processing that information and spitting it out 24/7, live. And that gives us the ability to really then sit back, you know, put our legs on the table and relax. That's what we want, right? That's, to me, in real terms, a return on investment, if you ask me. Okay, yeah, so we're looking forward to that day that this becomes commonplace, but again, we still have to go through the requisite validation, change management, and the hardest part, you know, getting the doctors to use it, right? I'm sure you agree to that. Thank you very much.
Thank you. That's absolutely phenomenal. Thank you. Oh, please do, by all means. Thank you. That was excellent. And I have to say, one of the things that occurred to me is how native you are in the AI lingo as well. When you were explaining some of the data architectures there, I was trying to wonder, are you a professor in data and technology? So it's interesting how, to the point that you were making, Haris, it is that, you know, AI won't replace doctors. Doctors with AI would replace doctors, and you're evidence of that in that you're an AI native now in how you're embracing it, but also laying the foundations for the future. And there's a huge amount of takeaway from that. Thank you very much. And Haris, just to bring you into that discussion as well. So you've heard very transformative examples, and you've also been a part of institutions, and there are many of us that say, whilst the NHS is great in many ways, it also has its challenges in many ways. Do you have an example of a transformative deployment of AI that you've seen that really that was the moment you just thought, you know what, yeah, something's changed here?
I mean, with a lot of these things, we're still waiting for the big transformation. Earlier in the week, we were talking about the difference between faster caterpillars and turning into butterflies. And that's where AI meets business or clinical transformation, right? Rather than sticking it onto sort of existing processes. But one of the sort of early signs of what is possible is, again, going back to the chest X-ray example, is something that we've seen in southwest London with the transformation of the lung cancer pathway, where traditionally, you know, if you were a patient, you know, with a persistent cough, you would maybe go to your GP first, they'll tell you to go away, then you might show up to the emergency department because it's now a bloody cough, you have an X-ray, they send you home, oh, it's suspicious of cancer, please come back, have a CT. The time to getting a confirmed diagnosis could potentially be 2 months, right? By the time you get a biopsy and everything. And what they've done in southwest London is use that chest X-ray AI technology in the emergency department to get same-day CT. So if the AI flags something as suspicious, don't go home, stay here. Let's book you in for a CT and get you closer to a confirmed diagnosis versus having to bring you back. And so in southwest London, they've gotten the average time from around just under 60 days to between 7 to 14 days in confirmed diagnosis, which means then treatment can start much earlier, and then you have a much better chance of successfully treating what is potentially a lower grade cancer. And that's really when the magic starts happening, when you take AI and then you say, hey, what if we delivered care differently? And the parallel I always think about is with digital banking, right? And I don't know what the experience was like in Singapore, but sort of a decade ago when we first started getting digital banking, it was basically just your statement on a website, right? And you would have to put in a pin in your HSBC thing, and then you log in. It'd take you 5 minutes to log in, and then you just see your statement, and you go, okay, I guess this is digital. But now you have mobile-first banks, and it completely changes your relationship with financial institutions. My business, Newton's Tree, we bank with a mobile-first bank. and I've never gone to a physical branch. and that's the kind of radical transformation that I'm waiting for in healthcare.
That's phenomenal. It just reminded me of I have a 6-year-old daughter, so she recently saw something on my table. She was like, "Dad, what's that?" And I was shocked because I said, "It's cash." Because she's grown up in a completely different world where you either use card. So I thought, okay, right. So that's what we call native, right? As you think about it. So thank you very much for that example. And it reminds me also of the transformative effect that democratization of technology has, because we've talked about how in genomics, for example, genome sequencing used to cost millions of pounds, and now you can get it done for like £100 in a very short period, right, through the evolution of technology. So if I come back in that order, Prof. Niam, let me bring you into that. In that sort of theme of going from what might be discovery innovation to truly transformative, where it sticks and it's embedded within the organization. What do you feel is the what's been your unexpected secret sauce to seeing that really work its magic?
Well, I think this really speaks about implementation. So how do you get people to do it, right? To use the AI. And this is a lot of process or design thinking going on, right? So I can share 1 or 2 projects that we've done. For example, one of the projects we've done with our polyclinics and our community health is a project called CHAM. CHAM is our chronic disease management program for population scale. So you use a WhatsApp chatbot that talks to you about your management of your blood pressure. It does not provide treatment recommendations, but it nudges you, right? So if you have the diabetes, hypertension, and hyperlipidemia, you will get a nudge. And this thing nags you, tells you, oh, please remember to take your blood pressure. Please remember to see a doctor. Okay. So to get that to work, we really needed to be on the ground to understand how do our polyclinic doctors work. I mean, the polyclinic bosses are here. So they'll say, every second in the polyclinic consult is precious, because you add 30 seconds, that's times 100 a day, right? That's a lot. So you cannot disrupt that workflow. Everything has to be smooth, fast, easy, right? And ideally, you don't have to spend minutes telling the patients about, oh, this is a new AI technology that I want you to try. That would add another hour to the day.
That's right.
So this is the kind of change management you need to think about in terms of how you design and implement it. I think that the magic really comes when you get it right and people start signing up and the doctors come and tell you, hey, yeah, that really works. Good, my patients are managing their own blood pressure or their diabetes now. That's a win, if you ask me.
That's absolutely right, because the challenge we have in healthcare is you're not a bank to say, okay, we're closed on Saturday, come back on Monday whilst we deploy the AI and see whether it works, right? You have people who need services, so you need to figure out that deployment in real time. So it's really important. I think it's important that we respect that from a clinical perspective. So really, thank you very much for that. James, I want to bring you in as well. So what would you consider the secret sauce in the experiences that you had for at-scale deployment?
So the secret sauce is, it's not that secret, it's data.
Data.
And not data means different things to different people, but what I mean by data is lots of it, captured easily, in a very fluid, frictionless manner, in an interoperable manner, meaning that it can pass between systems easily, and it's not just moving a PDF from one container to another, but what we call semantic interoperability. The meaning is interoperable. And so that's where language AI and the great platforms that you're building is building, and what we built in London with Cogstack is as well, is about making data interoperable in meaning. And then the data can flow in a frictionless way anywhere in the system where it's needed. And so then AI will take off, because data is the fuel for making AI, delivering AI, and finally, most importantly, monitoring AI, so observability. And that, a lot of the, there's a lot of organizational transformational things which are barriers perhaps, or obstacles to rolling out AI adoption, but data is a big one. The flow of data to the point of care. And that's how digital banking works, that your transaction flows directly to you. very, very quickly in a dynamic way, in a granular way, down to the individual transaction item, not the whole statement. And so you to be able to process the data in such a way, and if I had, a lot of money to throw at a problem, this would be what I would throw at first, because everything downstream will improve, not just AI.
So I'm tempted to build on that question, just because we have a significant clinical audience in the room. In healthcare, data comes from clinicians, and as well as from patients. So in the interactions that you do, you capture. My sister is a consultant ophthalmologist, so I feel entitled to be able to say this. The one piece of handwriting nobody can read is my sister's handwriting. So when you say data comes from doctors, what is the responsibility the clinicians have in enabling clean, usable, reusable data for AI?
So there is, I think the responsibility is in everyone in the system, okay? Not just the doctor and the patient. Everyone in the system has to be in charge of making sure the data is clean and high quality. Now, on the other hand, it's not about, I'm sure many of us have experienced scenarios where someone, we get nagged by our business managers or our clinical coders saying that you didn't input this properly, you didn't write it clearly, a nurse telling us that your handwriting is not legible, a pharmacist saying your dose is not clear. I think there are human factors here. When you are pressed for time, and every second in a polyclinic or whatever matters, I just want to do something quickly and move on to the next patient. The transaction is over, the interaction is over, whatever you recorded is recorded and it's done. But then you don't go back and look at it. Well, ambient AI will help with a lot of that recording, but it won't fix all the problems. There needs to be a whole life cycle approach of data. So that whole life cycle approach means that there should be everyone who interacts with the system needs to be empowered to be able to correct or check the data. We need AI systems to enable both the higher quantity and higher quality. So ambient voice AI would certainly help with the amount of quantity. For quality, you need other systems. And obviously observability is, again, other systems for that. Brilliant. So I would say that that's the secret sauce. Now, how to make more of that secret sauce is the secret. I don't have all the answers, but those are my thoughts.
But it's fantastic, so thank you very much for that. And I think in the theme of AI for change, change for AI, I think what I'm picking up from that is, in order for us to be able to leverage AI for the change, we have to change the way that we think about the importance of data. Otherwise, the virtuous cycle doesn't happen in the way that we would like it to be. So thank you very much for that. So Joy, can I bring you in terms of your thoughts on the secret sauce, where you've seen it work and work properly at scale?
Fantastic question, and great discussion. But if you want to bring change, the first thing that you need to bring change, and we heard it over the last 3 days in the workshop, is to then build trust. And how do you build trust in your system, particularly to believe that technology is going to help you in doing stuff? And we have had this experience when laparoscopic surgeons moved to the robotic surgeons with better outcomes and all of that. I think few things, and Professor Eugene will love me because he loves terms with C. And one of them is actually consent. And can I ask the audience here, with your permission, how many of you use consent when you are using AI in your system, particularly when you are interacting with your patient? Do you ask them that we are using a mechanical system or an AI while making your clinical decision? Raise of hands.
It's not an evaluation?
Not an evaluation. Don't worry. So that's a fundamental way that we would like to build trust in systems, by bringing in consent, bringing in consideration, compassionate consideration about doing. Compassionate consideration is not just about the patient, but also about the empathetic way by which you deal with your worker. And to see, and we had some brilliant examples in the morning today, how you go about in enhancing your competency to actually provide that compassionate care that you are going about in using the technology and all that. You know, a couple of weeks back, I was at Ireland talking about in a health ergonomics conference, and I said, despite whatever you did, I really didn't want to put it on a slide, but it was all over the internet, and it's, you know, quoting me saying, humans will continue to heal humans. And, you know, irrespective of how you want to form the doctor over the next few years, it is a human being which will ultimately go and heal another human being. And to do that in a more informed way, how do you then bring in certain trustable, you know, AI or algorithms and others so that he can go about and do that at the bedside in an appropriate way. The final thing, because we discussed about the data, and I think it is going to be very important to instill trust in your systems, is to then look at confidentiality, privacy of the data that you know, the patients are having, or the way you are looking at it. And AWS is here, and they have some robust way of doing it in way what we call as confidential computing and others. And that's going to be the cornerstone, how you use privacy-preserving technologies and computing to actually deliver that. So that's the way, possibly, you know, 3 or 4 of these C's to actually go about in building trust or as a secret sauce in your system to take care to that level that you want.
Thank you. That's absolutely phenomenal. And that notion of trust, we often hear about the very hard factors, the technology, the change, the use, but we don't often hear about the trust, the important the relationship element, because ultimately medicine is a practice of trust. Can I build on that for once? I just ask you a follow-up question. So in the UK NHS, we say that, not the UK NHS, actually, data suggests that the average health literacy age in the UK is, guess. Any audience in the room? Anyone wants to guess? Throw out a number. What is the average health literacy age, you feel? I mean, remember, it's an aging population as well. So what would you say, roughly? Any guesses? Oh, you've all read it. Yes. So apparently the average health literacy is 12 years old. So when you're putting out all these scientific material, disease awareness, all that kind of stuff, the majority of the population, it just goes way over their head. So in that context, how do you build trust in AI when the average health literacy age is 12?
Skilling. And skilling and competency are such a personal behavioral perspective that when you see that one of your peer is actually doing it, you would take it to it, right? Because that's the way you are going about in doing this. And we have had in past several examples in healthcare. And I think one of the ways by which the caterpillars have become butterflies in different transformation journey across the healthcare is by actually going about and understanding the skill, how to shed their shells and become butterflies and move on into this. But one is the other perspective is from a healthcare perspective, it is going to be very important. And I'm sure when the next Joint Commission audit is going to come and knock your doors from the 8th iteration perspective, they're going to ask you the competency, particularly from nursing and also from the physician's perspective. What is the competency level, what is the skilling level that you have put in to take AI solutions in your system? What have you trained them with? How have you assessed them that they can skillfully and in a safe way use this technology to deliver the care at that? And I think if you begin that journey, particularly in NHS, you'll suddenly see the 12 has become 24.
Sharif, can I add a thought there?
Yes,
please. Particularly when it comes to public health literacy, I think ChatGPT has been one of the greatest blessings in that front. And it reminds me of when we had the advent of personal computers. And Steve Jobs had a great quote, which is, he saw personal computers as a bicycle of the mind, as a way for us to just exercise and express ourselves in a way that we couldn't do before. And I sometimes think, particularly for public, at the stage that we're in with AI is where I was with Windows 95, which is I just spent my time reading Encarta Encyclopedia. and playing Minesweeper. And that's a good thing. It's a good thing, right? Like, just play with it and read Encarta Encyclopedia. And it doesn't have to always be about productivity, particularly for the patient, right? And one of my favorite uses, my personal use of ChatGPT, is just to test ideas. Like, someone will say, James will say something, or Prof. Niam will say something, and I will have an idea, and I'll just type it into ChatGPT, be like, hey, what do you think? And it will trigger other thoughts. And it's not because I'm trying to do my work or achieve a task. I'm just playing. I'm just the 8-year-old me, or whatever I was. I don't want to date myself. But just playing Minesweeper or Encarta Encyclopedia. And I think that is a really powerful tool for patient education. And we know, I think it was in Dubai or Abu Dhabi, where they've made a nationwide deal with OpenAI to give everyone free access to ChatGPT. And I think that will have a significant positive public health and health literacy impact.
Thank you very much. I will, do you want to build on that?
Just build very briefly. Play is how people learn. How our children learn. And play means you not just the fun parts of play, you also learn the weaknesses. And that's how you build the trust. So widespread adoption in safe spaces, in safe domains, where you can play without hurting yourself too much, is where people will develop their own literacy, self-literacy.
That is phenomenal. Thank you so much. Play is how people learn. I'll always remember that. So when my daughter's telling me, Daddy, I can't do my homework, I need to play, I'll be like, is she learning? Is she not? I don't know. But thank you. That's a good takeaway. Now, we are in an AI conference. I have a lot of questions, and thank you very much for the questions that have started to come through. So we'll go through to the audience questions. But we thought what might be a really interesting one is if we asked AI the first question of the conference. So go on. So this is entirely AI generated. So while we were discussing AI transformation, many healthcare workers are concerned about job security and role evolution. How are institutions approaching workforce redesign, and what new roles or skills have emerged as a direct result of AI implementation? Anyone wants to kick us off?
I think I had a better AI, and I have already answered that question.
So there you go, Sujoy.
I can chip in. So I still work in the National Health Service, and one of my other roles is I'm director of the National Fellowship in Clinical AI. And it's a national training program that is designed to help early and mid-career healthcare professionals to gain AI skills, so that when they become consultants or attending level healthcare professionals, they can be essentially AI leaders in their local institution. So that's one of the ways that the National Health Service has invested in preparing the workforce by creating educational pathways, but it's a drop in the ocean of what's required. But it's an example of some of the things that are happening.
So I just want to build on that. So we had a similar thing in Singapore where there are lots of courses in AI, but there's always a reluctance to take these courses, either because they are too long, they are too technical. Just the bar is just so high, right? You've asked somebody to go from zero to say, okay, now you learn about Python scripts, right? It's a bit hard. You know, you're 50 years old, you have to kids. It's not going to be easy, right? So one of the ways to do this is to have sort of a tiered way of getting people on board. Like you start with the fun things, right? You start by teaching people, okay, learn how to do some prompting. Okay, that's fun, right? And as they get into it, then you graduate them at different levels. So at least at the university level, we've been offering what you call continuous education courses, right, for AI. We also have a master's in biomedical informatics offered by the Division of Biomedical Informatics, and we have been seeing a very steady uptake of people coming through the system. And one of the questions people ask is, what do I do with this skill? And the answer is, take this skill and implement something in your workplace. And that's been a consistent message in the last 5 years or so that we've been doing this. And to your point, right, you will learn something as you do your project. And provide, especially if it's fun, right? So then you will learn something. And more importantly, this speaks of a more, sort of a rising tide kind of situation where everyone needs to be uplifted. And we can create a whole ecosystem around it. It's not just I teach you and you implement. there's a whole ecosystem, right? Meaning there are people who are more interested in the clinical validation side of the house, especially the clinicians. There are people who are more technical. They really want to go, deep into the actual mechanics of building these tools. And yet there are people who are the extreme, right? Who really want to build language models from scratch, for example. So I think this is a nice time to announce this, but Singapore, we have been funded to do a healthcare foundational model. It's called Symphony, right? And the idea is to address all these issues about inaccuracy or inappropriate answers, right? Hopefully through a national effort we can do this. And I think on the theme of this conference is AI for us, AI for all, right? This is one effort that requires everyone's help. I'm looking at John T, I'm looking at Eric sitting behind there and others. We really need everyone to be part of this. It is not easy to do that. And this is what I mean, the ecosystem. Everyone should get involved in this because everyone at the end needs to trust the system and have a stake in this particular model that they are built in.
Correct. Thank you. Any other?
Well, I would say that what I'm in my 10 years doing this, 10 years ago, I could hardly find anyone interested in this topic, or even the people I found interested in the topic had very little skills to be able to do it. And now there are many, many people out there learning. And they're cross-fertilizing each other, they're learning things outside of their comfort zone. And this was not present pre-pandemic. And so I have loads of clinicians picking up informatics skills or data science skills, analysts picking up clinical knowledge by just mixing around with clinicians more. And so coming out of the back offices and interacting with clinicians and healthcare professionals and operational managers, understanding workflows and there's so much more conversation between the different groups, such that you're getting clinicians who become informaticians and informaticians who become clinicians, and that sort of crossbreeding of specialties.
That's brilliant, thank you. And I think we will see that the definition of what you are, right, starts to evolve. And I think social dinners will become very interesting. It's like, so what are you? Well, some say I'm a doctor. Some say, I'm an AI specialist, so what are you? That will be really interesting to see. Thank you very much for sharing your thoughts on this. We have some very good questions from the audience. And let me hope I don't get this wrong. Where is the first question? What have I done with it? Oh dear. Oh dear. User error, always with AI. There you go. Yep. Okay. So. Can we see it? I'll read it anyway, if you can't see it. So the first question is, how do we employ AI in aged care, especially for seniors who may not be so tech savvy? And you need to realize the context of this is we have a super aging population in Singapore. So essentially the people that whose lives we hope to transform are of a much elder, of a certain generation. So any immediate thoughts? Prof. Niam, maybe I'll start with you, if that's okay, given this is your lived reality.
Yes, absolutely. So one of the biggest challenges for aged care is how do you access them? How do you get them to use something, right? So there have been many attempts at this in the past years, and I speak from personal experience. My mom has 3 Apple accounts. Why does anyone need 3 Apple accounts, right? We have 3 phones. Well, the problem with her is she can't remember her passwords, right? And she tells me she writes it on a piece of paper and she gets it lost. And so I had to, Apple's security is so high, I can't break it, right? So I had to create a new password. And guess why she needed 3 accounts? Because she needed to log on to apps. You need to download an app, you need an account, right? So so that creates the first huge barrier to access patients who are aged. And we really cannot make it hard for them to access. So to solve that problem, we decided to use WhatsApp. Okay, it was very hard. We had a lot of security clearance. And the motivation from that was really simple, right? She had really hard time getting an app. She has no problem sending me good morning stickers. Every week, she would send me a good morning sticker, Chinese New Year, forwarded many times, the videos. no problems. And she's 80, right? And she's perfectly able to do that. So I think one of the key things about employing AI is first, how do you get access? How do you get the attention of the elderly to do this? And then down the line, there are other important things such as how do you send the appropriate message? It cannot be too complicated. It has to be motivational. It must activate them to do something. And the last thing I would mention here is aged care is not about the aged alone. Many times it's about the caregivers as well. So somehow you've got to pull both of them together, the caregiver and the patient, right, to be able to effectively nudge them towards a better behavior. So I would say that that will be my experience at this point. And going forwards, hopefully new things can come up, right, to help us do this even better.
So I love the way you described it, right? So often we fixate a lot on, we think the entry for AI needs to be X, so we keep pushing and pushing. But I like how you described that you met them you met her where she was, right? Yes, we had the three profiles, but at the same time, WhatsApp was incredibly accessible. So then how do we reimagine access using what it is that they're comfortable with, which helps to reinforce trust? I mean, Sujoy, I'm intrigued from your perspective because you operate AI at scale within a very complex health system, within a very diverse environment within you operate, urban, rural, young, old. So what's your thoughts on this question?
One of the things that we don't have the dearth of in India is people, right? So the best way to do this is through caregivers, and have caregivers who would possibly follow up with these people, particularly in elderly. We did a project where we actually looked at it from people living with Parkinson's disease, and we have had some very good success about looking at their activity of daily living and the way that the technology itself is very good, which actually provides what they do across the different times of 24-hour cycle, and then when to go about and do the appropriate intervention for these people. But what we are also seeing is that I'm not going into extreme ages where we are looking at people above 80 years, but between 65 to 80 years in India, particularly in semi-urban or even in rural area, now that we have better internet accessibility, a lot of people are behaving as if, elderly people are behaving as if they are 21. So we are learning more about those elderlies as well and their habits and all of that. WhatsApp, of course, is a very, very good channel, but we are also seeing it in other platforms as well.
And I think that's a very important point out, because often it seems like we have a preconceived view of what we feel the elderly might be able to cope with. But what you're saying is, actually, what you're seeing is, 80 is the new 25 kind of thing, and people can reimagine themselves in so many different ways. That's absolutely fantastic. Thank you. James, do you want to?
I think one aspect that we overlook is that the elderly are not homogeneous. And just like a patient who in their 30s or 40s of it is not homogeneous, you wouldn't compare another 140-year-old with another 48-year-old. The elderly are not homogeneous. And so therefore we have to have a very, just like we have personal medicine, personalization of care, there's a personalization of user interface, of UX. And that needs to be adaptive to the user, and whether it's aged or not. And age people have, some age people will have a certain level of literacy and others won't. Some will would love to have 3 Apple passport accounts. And so I would say that we have to appreciate the diversity and heterogeneity in our populations that we treat and their caregivers. And so our tech needs to be able to cope with heterogeneity.
That's incredible. We need to remember that people are individuals versus numbers. I think that's incredibly powerful. Thank you very much. There's another very interesting question that has come through, and I think I can't remember who told us this, that they went for a course at Harvard, and they have a very specific course for how you speak to your CFO. I don't know whether you hear this, because often that's the challenge, right? Doctors, we speak all the passion, we can talk about the patient care, we can talk about all of that kind of stuff, and still what we end up with, yes, yes, but it is $10. Who's going to pay for it, right? So can we talk this through? How do we justify the cost on implementing AI systems and infrastructure without a clear future idea if the implementation will be effective and or efficient? Do you want to kick us off?
Yeah, I mean, this is sort of my day job. and doing this in the NHS where we have no money is even harder. So this is exactly the market failure problem that I'm talking about, or that I was talking about earlier, right? And you have two challenges. One is the cost of implementation, and then there's the cost-benefit realization at the end, or the benefit realization at the end. So one of the other dirty secrets, a lot of dirty secrets coming out today, is that actually, with a lot of diagnostic technology, like we had in the first generation, for a socialized healthcare system, they do not make sense. And that's a reality we have to accept, is that a lot of them, like I was speaking to my friend who's chief AI officer at University of Texas, Peter McCaffrey, and he was saying, I was like, how many AI products do you have live? He said 47. I was like, 47? I was like, I do a lot of AI. I can't think of 47 good use cases in diagnostic. And he said, Haris, it's very easy. We use it for speculative screening. So we can funnel patients to our clinical services and generate revenue. And I said, that makes sense. If you're incentivized to do more activity so that you can generate revenue, then diagnostic AI is perfect because it's very sensitive. It will find any abnormality and say, hey, you should biopsy this. You should do another CT, do another MRI. In a socialized healthcare system like the National Health Service and the public systems here, you're thinking about cost effectiveness. Like, should we really do this? And humans are much better at that, right? And in order to prove cost effectiveness takes a while, right? You have to see the outcomes and the pathways that these patients follow to understand what is the true cost saving. And we just don't have a lot of that evidence. And the reality is, with a lot of diagnostic AI, it increases costs. And that's not to talk about the implementation, because some of them will save costs. Things like stroke care, like I explained with the chest X-ray triage, and you guys have done here. Some of those are cost saving. The problem is that learning which ones are cost saving, which ones are not, is very expensive. And that's why investing in infrastructure like Prof. Niem has becomes critical. Because then, if you can spin up a project in 6 weeks relatively cheaply, then you can answer the question like, hey, is this going to save me money? And that's going to be the answer.
So I guess let me push you a bit harder, because I think implied in this question is there's somebody in this audience that has, actually, in fact, it was voted up by so many people, so I think there's at least 15 people in this audience that have a phenomenal idea for something AI, and they know that their manager is going to say to them, so what's your business case? So help them. In 30 seconds, what's their pitch? What's their business case? Come on.
I mean, so it's hard to answer, and it's one of the challenges without understanding the micro incentives of your economic structure. As in, whose budget are you asking? Are you asking radiology? Is it oncology? Is it the hospital CFO? Is it the cluster CFO? Is it MOH? Who are you asking? Because they will realize different impacts on their budget depending on who they are. But ultimately, the mistake a lot of people had made historically was talking about sort of phantom savings, which is, we're going to save 5 minutes of nursing time.
Correct.
And we'll do this across, 1,000 nurses. And hey, presto, we've got 2 free nurses. But that would require you to chop the finger off every nurse and put it together to get a new. And that's not how accounting works, right? And so we have to talk in real cash releasing benefit, right? Which is the CFO wants to say, look, I'm going to give you $50,000. I want $100,000 in cash, not in a nurse's finger or in 5 minutes. I want it not in bed days. I need it in cash. And that's where AI implementation with service redesign becomes critical. Because often if you're not changing the workflow, it's very hard to pocket the cash.
And that's really important. I have a view that once activity comes into a health system, it's almost impossible to deliver any savings out. So this notion of prevention and keeping activity out of the system, especially in a system like that, is absolutely vital. And perhaps for the CFO, that's the focus, right?
Yeah, and just on that point, I think the really fantastic opportunity you have here is at least compared to the health service, is the better integration between primary and secondary care. And as someone who spent their entire career in secondary care, I wish I could deploy more algorithms earlier in the patient pathway, and that might avoid any hospital engagement at all, and that's when you get real savings. Yeah.
Fantastic.
And but essentially, the cost is borne in one part of the system, and the benefits are often derived in a different part of the system at a different time frame. And so trying to align that, if you have got a small AI project in one department, is that you're going to have to work out where the benefit arrives, and you're going to have to team up with that bit of the system. And so that you go to your CFO together with a single project. So you need to converge with other people in your system, and you need to network out all the different bits where all the stakeholders are in the system, which derive the cost and derive the benefits, and who will end up spending more.
I really like that. So the context of system redesign, just building on that question, that ultimately, if you fixate on the business case of your AI, it's not going to go anywhere. If you fixate on the business case of the system change, then you're talking enabled by the AI. Thank you. Did you want to add, Prof?
Yes, I'm going to advance something slightly controversial. Can we not talk to the CFO?
Oh. Oh.
To be fair, it's a bit from what Dr. Haris and Dr. James here has mentioned. Really, why do we have to talk to the CFO? Why? Let me explain. There's a good reason for this, right? The reason for this is because AI is emerging or going into production kind of technology, right? It will take months, years to show value, and you are asking the very people who are supposed to demonstrate value, they are probably the worst people to go and figure it out, right? They'll come up with ideas. Oh, I'm going to save 1 hour of nursing time, and then you chop off their fingers. Yeah, I mean, we'll come up with all these hypothetical numbers, right? And as far as CFOs and corporate presentations go, oh wow, we save $1 million, but of nurses' fingers, right? So it doesn't make sense, right? So I think probably the better way of doing this is to consider these as innovation budgets, okay, or strategic budgets. And that's exactly what we have done. In my organization, we invested in AI, not from a CFO standpoint. Yes, the CFO signs off, but as an innovation budget. That's important, right? Because innovation budget implies that these things are high risk, they can fail. Okay? And it also implies that it's strategic because it will take 2, 3, 4, even 5 years before you see any result, right? And when you have that, your stakeholders are no longer bound by the fact that, oh, I can't do this project because I cannot demonstrate return on investment. Rather, they'll be thinking along the lines of, how can I use this AI tool with these resources to get the best out of this? And then I show benefit, and then I talk to the CFO. So in that order, right? And Singapore is really well set up for this, right? And in that space, I would say that Singapore is extremely well funded from that grant perspective to do that. So I can say that we have every level of tranches of funding from really exploratory research all the way to implementation type AI. And I think that's something that gave us the ability to innovate in a safe space, at the same time pick the best projects that show value for deployment. So in summary, don't meet your CFO.
You heard it first here, ladies and gentlemen. Do not speak to the CFO. But the innovation budgets as well. So for those who are in leadership, perhaps the message is, how do you help your innovators know and understand how to access the range of innovation budgets available, certainly in Singapore, to be able to realize your thoughts? Did you have anything further? There's one more question I'd like to get to, if there's any. So there's a very good question here from a colleague that talks about the reality of working with AI. So if I don't agree with AI assessment, what should I do as a doctor? If I agree and I am wrong, I am liable. If I disagree and I am wrong, I will be doubly fired. Right? James, I want to start with you.
Certainly not. You don't want to be doubly fried. So having used stroke AI algorithms before, there are plenty of times where I look at the image and the interpretation and go, this is wrong. And I'm going to just ignore it. Now, I am in a lucky position of seniority and experience to have a degree of confidence in that. Even sometimes when I go back into back and look at it, and sometimes I say, okay, actually the AI, I can see what the AI was trying to do, and I can explain it, and I can justify it. And I would say that in this scenario, you have to be able to justify it. And so just like when dealing with another human being in an MDT or in a discussion where you don't come to the same decision, you have to be able to justify why you come to a different decision. Being able to justify your chain of thought, like how these modern reasoning LLMs do it, the chain of thought provides the justification. Show you're working. Now, what this means, though, is that you need to be able to show they're working. If you don't know how to show they're working, you shouldn't be using it you're not using it properly. Okay? And so what it means is that people who are using the AI must be people who are able to check the AI's results or interpret it correctly. And therefore, people who use AI will have to be nearly as bright and nearly as able to explain their position. And in a situation of liability, then I guess that's a different issue. That's a societal issue. Who's responsible? Sorry.
So I really want to bring Sujoy into this because I think your perspective would be incredibly powerful. But before I do, let me push you a bit further. I'm a junior doctor. I've started to work in your practice. You've deployed AI. I'm working on it, and I make a mistake. What will you do?
There would be a learning lesson and a debrief session for everyone, and that would be the way to learn. I mean, rather than
But we're in a stroke service. The consequence of it might actually have been fatal.
That would have happened even if there wasn't an AI. Okay, even if we didn't use an AI, if a junior doctor made a mistake, there needs to be a debrief. Human beings make errors, just like AI systems. And so the debrief has to be transparent. There has to be an attempt to be blameless. That's how you learn.
So the key message I'm taking away from that is AI deployment must also be accompanied by the right kind of organizational culture and learning approaches. And then you end up with the best of both, which is incredibly powerful. So
I completely agree with James, and the two things that we want to understand into this, that human-machine conflict, and we did raise this in the last 3 days in the workshop as well, is bound to come in, particularly in these situations. And I always give an example of a nurse using a clinical deterioration at 3 a.m. in the morning when she doesn't, possibly in a ward where she doesn't have anybody else to discuss through this. The two things that people should do, the clinicians should do at this time, they should put in the medical record the output of the AI with the time instance. They should put their justification of why they have overridden the AI's recommendation and keep it in that way, and how they have gone about in doing this. Because that's very, very important medically later on as why you have not taken it or why you have gone about in taking that from a practice perspective. The other thing is this, that all of these issues, wherever you are having in a conflict, and we were even discussing this yesterday, is then something that needs to come to your governance at some point of time, which would actually look at the overall effectiveness of rolling out AI solutions in your organization. And you would have to then look at how effective this AI is. Is it then giving you certain prompts or certain outputs which are possibly not clinically relevant at that point of time?
Sharif, can I share a story? Because we've had this happen in real life. So one of the first things that we deployed at Evelina Children's Hospital in terms of a commercial product was pediatric bone age. solution. So for those who are familiar, this is where you use the hand x-rays of young children to assess their developmental age. And it's a perfect task for AI because it's very boring. You essentially look at the image and you have an encyclopedia or an atlas and you comb through it and then you sort of match it and you're like, patient bone age is 4 years old. And we deployed this AI, and we had tested it, and then we deployed it, and then about 6 months into the use of it, a group of the consultants said, they came approached us and complained, and they said, the AI is making mistakes. And I said, okay, interesting. Explain to me the mistake. So for those of you who are not pediatric radiologists, when you're doing a bone age assessment of children under 4 years old, you're supposed to ignore the carpal bones. So the wrist bones, you should not, because they can be misleading. What was interesting was the AI was correctly ignoring the wrist bones, and it was the consultants who were wrong. and so we had to have a very awkward conversation and be like, hey, I know you've come to complain, but actually, I'm going to complain about you. But what it highlighted, and the thing that this question is missing, is not what is the doctor's responsibility, is what is the institution's responsibility. Because we realized, like, oh, we have no policy about this or process to deal with human AI conflict resolution. And it's not to say that the doctor has no responsibility, but just like with data, there's responsibility on different parties. And the thing that, in my experience and opinion, hospitals have not been doing their part in setting up clear guidelines for their staff on what to do. This is too difficult a topic for individuals, whether they are senior doctors like Prof. James or residents and juniors, to be resolving on a case-by-case basis. And, God forbid that was an oncology MDT decision. And the oncologist says one thing, and IBM Watson says something else. What do we do with that disagreement? And that's the real challenge, is less about what does the doctor do, but what do our institutions do?
Thank you. That's incredibly powerful. Thank you very much. We have 5 minutes left in this conversation. So what I'm going to do is I'm going to ask you just final questions and takeaway. And Haris, let me start off with you. So there you are. You have an audience that's now totally convinced that a world without AI does not exist, and fully in on the journey, and looking to go beyond pilots to drive meaningful change. So then, what's your one piece of takeaway advice for the audience for what they can do differently going forward to really see meaningful change through the use of AI?
Oh, that's a tough question. So, where we are today is where we were with computing in sort of the 70s and 80s. And there was lots of very famously bad predictions. I think there was the IBM executive that said something like, the world market for personal computers is 5 or something like that. And so anything I say about the future will be equally incorrect. I think what I can safely say is that when AI is deeply embedded and transforming our health system, it will be unrecognizable. And what do you do in the face of such radical change is you have to be ready to relearn.
So be ready to relearn. That's a very powerful takeaway. Thank you. Prof.
Sure. He said what I wanted to say, which is when we attend a lot of panels and we give a lot of talks, when you walk out of the room, what do you take with you, right? Most people, oh, that's a nice talk. But I really would strongly encourage, and in fact, I won't encourage. I would say, please think about get educated in AI, getting an education in AI, and it doesn't have to be a formal one. It can be just willingness to do a project, willingness to think about it, and the easy way to do this, right? If you are sitting at your clinic or your office and you're typing an email or you're writing a note and you're frustrated, right? It's 6 p.m., everyone's got, clinic's over, I still have to type these notes. Ask yourself, can AI do this? If AI can do this, you should get AI to do this, and you'll not be sitting here feeling upset for yourself, right? And what does it take for you to learn that? Not very much, to be frank, right? You go online, watch a few YouTube videos, and learn how to prompt engineer some of these things, and you get that answer, right? So that's an easy win. And then, as you think more and more about it, then you quickly realize that, okay, now, if I really want to automate my workflow, I have to get a bit deeper. I have to start fixing data source issues. We have to start fixing algorithmic issues. And then you learn, right, how to do this. And at the end of it, you can tell your young, hotshot junior doctor that, hey, you are still typing. I finished my job. That's a real win.
Fantastic. And I like how practical you have made that, because that is something that we can all do tomorrow. In fact, as you were saying that, it was making me think, I'm facilitating conversation in AI, and I have a pen and a paper, and I'm taking notes. That's disgraceful. So my commitment, CHI, next year, if I am here, I will have my AI companion summarizing the discussion as we go. That's my commitment. Thank you. James?
I'm going to try to combine the both of those. It's about being, again, you to be able to unlearn, but not rather unlearn to be adaptable. Because things are moving so fast, things are very unpredictable. What you, some course material you write for last year is outdated already on AI. And so you need to be learning in incremental steps and be able to pivot really quickly. So you have to learn lots of different things, and you may not necessarily need to know them in great depth because you may need to change direction, but you do it incrementally. And this self-learning, I mean, I think most of my students and even my children now are self-teaching themselves from watching YouTube videos and things like that. And so a lot of this is going to be self-learning. There will be courses and all that big organizations can provide, but big organizations, by the time they produce and publish it, it'll be outdated already. And so people are learning so fast. And I would say that to be adaptable is to be ready for healthcare in the next generation. Whether it's going to be AI or whatever the next amazing thing in 5 years' time it will be.
Thank you. Be adaptable. I like that.
What I take from this talk is that don't talk to your CFO. But jokes apart, I think I'll go a step more, and I'll talk about shared insights when you are learning. With your colleagues. Collective learning is a very, very productive and very, very important tool. And then don't forget to communicate. Again, it's very important that you communicate both horizontally and vertically in your system, and of course with the patients.
Thank you. Thank you very much. And with that, ladies and gentlemen, let me try and summarize. And then, firstly, can you just give them a round of applause? Thank you. Thank you very much. It's been a really refreshing conversation, and I really love the honesty. Also, that don't talk to the CFO bit will go with me for a long time. So thank you very much for that. It's going to be impossible for me to try and summarize this. Actually, what would be really interesting is if you ran the same thing, if you recorded the video and you ran it through ChatGPT, is it going to have the same summary as me? I don't know. Let's see. So my key 3 takeaways from this conversation that I just wanted to remind everybody of. So number 1, which we were reminded of throughout this discussion, is the triple aim. Ultimately, we're looking at AI not necessarily as a tool to play, but as a mechanism to transform people's lives, to improve accessibility, to improve affordability, and to bend the cost curve. So it's vitally important that journeys around transformative use of AI at scale are grounded on the triple aim. And we heard some powerful examples of that. Thank you very much. We also heard a lot about how scale requires organizational infrastructure. Whether it's cultural infrastructure in how change is managed, understood, mistakes are managed through the process, through to capability infrastructure. So you go from just being a doctor to now being a doctor with AI and everything else in between that. So institutional change is critical to be able to ensure that there is both the space, the opportunity, and the ambition to be able to realize the benefits of AI. And then my third big takeaway was around trust. The fact that at the end of the day, we have to build positive, relatable trust with the broader population around the value and the benefit of AI. And in doing so, recognize that we don't just have a homogeneous population. We have people across different age groups, different languages, different demography, different experiences with technology. But if we don't build the trust, then we miss the opportunity to leverage the true promise of what AI affords us to do. So thank you very much to you, panelists, for this wonderful conversation. Thank you to the audience for staying for this conversation. And with that, I think we come to the conclusion and the end of this session. Thank you very much.